I am going to go ahead. I am going to make 11.6 extra credit. I don't think I did that today.
No, but thank you.
Yeah. Again, you're lucky. This semester I'm trying kindness out. See how it feels. I don't think I'm going to be continuing it. It feels gross. Doesn't feel natural. So you took me at the right time. And that was the section that we did at the end of class last time with the hypothesis testing for chi-square. So, yeah, you're welcome. So, with that said, are there any questions from any recent homework stuff? Anything? So maybe the first thing we can do, because I think in the video solution thing I made for the practice final, I didn't do chapter 11 because that semester we did it in class. So let's go ahead and do number 11. I mean, did I say chapter? Number 11 on the practice final, which is funnily enough an example from chapter 11. Yeah, thanks, Bill. Pretty cool with that? Anybody need a little more light? You guys good? You guys never really let me know how you're doing, so I'm just going to assume somebody needs a little more light. It's not bad. It's not nice. Okay. Now I was trying to find. So earlier this semester, when I didn't really need it, I found plenty of studies that had chi-square analysis of the statistics they analyzed. And now I just couldn't find any from recent times. There are a couple of studies done recently that are bad news for cannabis users, but none of them had anything about chi-square in them, so damn. So I want to look at this problem here. I don't think we did that one yet, did we? No. That's right, because I didn't have this last time. So let's, if you need to borrow a calculator, come on up and do that. So let us do this thing together. First thing is, let's do this. So let's fill this in a bit. This column here should be easy as hell, right? What goes here?
51.
Yeah, so I just can copy. So I have to give you the observed, obviously, because we're not in a situation, we're not going to observe. I got to tell you what was observed. So 60 QBs, 31 Cs, 60 Ds, and 37 Fs. And there's a sample, 342 students, so hopefully that adds up to 342. Let's see, did Jeff get it right? Looks like maybe it does. Sure. Now, this one's gonna suck a bit because this one is, more true to life. I just happen to have a sample of 342 students. Are the percentages of that number going to come out nice? No, not necessarily. Damn it. So, let's immediately go to the calculator and build things there. So I'm going to clear all this out. It's kind of nice to have a nice big blank slate to look at. Clear all that out. Whoops. There we go. That's a nice. There you go, Jeff. Frame it nicely. Okay. So I'm going to put into L1, I'm going to put the observations. Okay. Zoom in just a little bit. All right. Fit everything up here. Yeah, there we go. Now, in the expected, so that's going to be L2. what should go in? How do I calculate what's going to go in that first spot in the expected column? What do we know about A's and expectations? How many do I expect? What do I know about how many expect to get A's?
13%.
Yeah, 13%. So what should go here will be 13%. 13% is 0.13 of means times what?
51.
Nope. 342. There we go. Let the calculator do the work, right? So this will be, where'd it go? 0.2 times, is that cool? 20% for the next spot, right? 20% there, yes? Bam! And then 34%, and then 20% again, and then 13% again. Bam! So you should end up with that. So be really, really careful. This has come up a couple times. The percentage I take is never of the observation. Never. The expectation happens if I've made an observation. If I haven't, there's an expectation, yes? So it can never be dependent on the observations I made. It's just dependent on how many total. 13% of the total should fall into the A's and so forth. And not really should, but that would be the expectation if it followed that pattern. And does anyone understand what this sort of represents roughly? Anybody? Where's the tallest point? Yes?
Normal distribution.
Yeah, it roughly approximates a normal distribution, right? Which is what the whole bell curve is about, and teachers are supposed to make tests that have very few A's and a lot of C's and very few F's, and if you don't, you're crazy, whatever. So, I mean, that would be a normal distribution. So what's happening here is somebody's interested to see if the past student performance falls into a normal distribution or not. And when I asked you before if something was normal, did it have to be perfectly normal for you to say yes? It just had to go up and come back down, right? Weren't we doing that a while back? It looks roughly normal, right? So even if it's not exactly the same as what would be expected, maybe it's not far enough away that maybe I would still say it's roughly normal. So it's sort of like what we're testing here. This test is going to say, how far away from normal is this? Because of the way it was set up. Okay. Now, so again, L1 is the observed, L2 is the expected. So how do I construct L3?
L1 minus L2 squared.
Yeah, 11. And of course, how do I construct L4? This is going to be in L3, and this is in L2. You guys see that? It's so nice to just let the calculator do most of the computation work. We just got to tell it what the hell to do. So I'm going to go to L3, and I'm going to make that, so I'm going to go up to L3, and I'm going to make that parenthesis L1 minus L2 squared. That would be observed minus expected squared. Jeff, why do you keep doing that, dude? Bam! All right. You can use strange. Oh, this is good. This is really good. You having a good time? Well, maybe you should see over there. All right. I'm treating it like it's the camera's fault. There we go. Boop. Okay. So everybody understand what's happening so far? And again, you don't have to do this in the calculator. You could do each column, each row, calculate. There's nothing really wrong with that. It just takes longer. And then L4 is going to be one. You already identified it, right? It's going to be L3 divided by L2. Bam! So again, just to remind you guys, this tells me how far apart they are, which makes sense. Isn't this whole thing trying to figure out if the observed is far away from the expected? So of course the step in this should be subtracting those things. And then, of course, we should square that, because some of them are going to be negative, some are going to be positive. Same thing we did with standard deviation. What was standard deviation all about fundamentally? Can somebody tell me one word that captures what standard deviation measures? Distance. It's a standard distance I can use, correct? So, and this is distance also, isn't it? So it kind of makes sense. There's some analogies there. Okay. Does anyone remember what the chi-square score is for this kind of problem?
The sum.
Sum of what?
O minus E squared over E.
Yeah. That, of course, is going to be a formula you can just have sitting on your formula sheet. So that's going to be the fourth column. I just have to sum up the fourth column. I like it, so I'm going to quit out of here. I can either do this by going to list, math, sum. Remember this stuff here? I could do, so let me do it again. Second stat to go to list. I want to do math on a list. I want to sum up the list. I want to sum up list 4. Bam. 5.535. Now, am I done? Do I have any way to tell what this means at the moment?
Our chart.
Exactly. I like the way you said that. Use the chart, man. Did I bring any? That would be really useful. I got every other chart known to man. Did I bring a chi-square? I don't think I did. Well, shite. Somebody have one I could borrow from them?
Yeah.
Shame. So what do I need to know before I can use this?
Degrees of freedom.
Degrees of freedom. And for this kind of test, what are the degrees of freedom defined as? Is it n minus 1?
No, the categories.
Categories minus 1, which we spell with a K, of course. Because math people are weird. So the degree, how many categories were there involved?
5.
5. So degrees of freedom is 4. What's alpha in this problem? 0.05. I like it. So we look at 0.05, 4 degrees of freedom, 9488. Okay. What does 9488 tell me for this problem? What does that set up?
The rejection region.
Yeah. So if I get beyond this, I really want this to make sense. The only way chi-squared could be 0 is if the observed equaled the expected. Right? And then that would be definitely not evidence that they're different, because they were exactly the same. So I would not be able to say that it doesn't follow the expectation. So I have to get, not only do I have to not be 0, I have to get past all the possible variability in samples. I have to be further than 9488 to say, okay, this is looking like evidence that there really are different. Because 0 means they're not different at all. So I got to be far away from 0 to show evidence that they are different. Yes?
So if it was below 9.488, would you reject it?
What do you think we call this region here that is shaded? This is the rejection region.
Oh, okay.
Yeah, just like always. So we fell here roughly, right?
Yeah.
using my crappy scale, but we're definitely not in there. So 0 means there was no difference between the sample and the expectation. 9488 means you saw enough difference to say the population is probably different also. We didn't get there. So we have not found enough evidence, right? Somebody could argue that we found some evidence, but it is definitely not enough evidence. It hasn't passed that bar. So can we say, is there evidence this group does not follow the expected pattern?
No.
No, there isn't evidence. This group, and I know all my English majors out there are going to love this double negative, but too bad. There isn't evidence this group does not follow the expectation, which we now know is normal distribution. So another way to say this in slightly more English terms would be, we haven't found evidence to say this isn't normally distributed. In fact, I mean, really quick, you can't use this to answer this, hopefully, obviously, but where's the peak in our observed data?
C.
In the middle. Does it go up to it and come down from it? But is it symmetric? No, right? So then that's the question then. It looks like it's roughly normal. Is it roughly normal enough to not be in the rejection region? In this case, yes. We didn't make it far enough away to say it wasn't normal. I really want you guys to be there with me. Okay. So what if I did get exactly 0? Would that be evidence that it is normal?
No.
No, because it's just a sample. That could be a fluke. Yeah, I love it. I don't know. Was that okay? That was kind of quick, but I mean, these problems are very focused. I think compared to other hypothesis tests, we don't do the whole hypothesis test. We do the main things. How far did the sample get? Where does evidence start? That is the heart of a hypothesis test. How do you guys feel about that? I don't know.
Good. Can we do number 8 together?
This year?
Yeah, I feel like it should be way simpler to me, but it's not.
So just tell me, what does the z-score tell you for a data point?
Distance from the mean.
Be more specific.
Standard deviations from the mean.
All right, the number of standard deviations from the mean to that data point.
Okay.
All right, this is a little bit more specific question. So if a z-score tells you the number of standard deviations from the mean to the data point, and I'm saying what does a z-score of 2.14 tell you? It tells you that that data point is
2.14 standard deviations away from the mean.
yes.
That's all you want?
I would accept that. I would even accept above the mean, even a little bit better because it's positive, right? But away from the mean is beautiful. You guys, that is the question that I told you way back when was going to be on every test. And this is just not just this class, but in general, I sort of stopped calculating the percentage of people that get it right because it's not that great. But that's all a z-score can tell you. Why would the answer to this question never be an area? Where would you get the area from? You understand? How would you get an area related to 2.14? Yeah, so if I asked, what would a z-score chart tell you? Okay, that's not what a z-score tells you. Also, when are you allowed to use a z-score chart?
When it's normal.
And did I say it's normal? No. So it's like a double whammy on that answer. So an answer to this question is never going to be some kind of area.
Okay.
Z-score by itself is just a distance, right? Don't say distance is not good enough, but it is just a distance. It is a distance measured in standard deviations, right? So standard deviation is our choice for the standard unit of measurement. So we could choose to use inches. We could choose to use feet to measure apart two physical things. In statistics, the standard deviation is our choice for tick marks to measure distance between data points. So standard deviation is that tick mark. Z-score is when I lay the ruler down and just measure.
Okay.
Maybe?
How many
No.
questions are gonna be on the final?
I don't know. Normally on my finals, somewhere in the mid-20s.
Okay.
And that, of course, you know, is counting A, B, C, whatever, right? Because I always say it again, when somebody says 4 questions and they're all A through J, and I'm like, that's not 4 questions, what the shit? Maybe? Have you ever lived that experience?
Yeah.
It's only 4 questions, A through J. Oh.
Okay.
So that one wasn't too bad. By the way, this one would be extra credit. This is from chapter 10. Jeff, there you go, buddy. So this would be an extra credit problem. I think I mentioned that on the video.
Out of curiosity, was Canvas working for you today? Because it wasn't.
Canvas is, today is, it's shit, yeah. Which I was telling other people, I'm so happy I'm not teaching online right now. It's bad enough that it's down, just in general, yeah. If there's no other specific questions, I think I wanna make the final exam formula sheet, right? Because that normally kind of jogs people's memories about stuff to ask about. So Sebastian, can you? Thanks, man. There it is. Oh boy. So what's the final gonna cover? Does anybody know?
Cumulative, all of it, right?
All of it! I will tell you this. I'm not gonna make you do, don't write this down, but I'm not gonna make you do like this formula, remember this? Okay, so I think I said at some point, once we were past test 1, I was never gonna make you do that formula again. So I better stick to that, at least this semester when I'm trying to be nice. So the first real formulas we came across, I'm gonna put Z-score later because it came up really early, but it didn't really come into play until later. I don't know if anybody know. So the first real formulas that you would want to put down are from chapter 3, if I remember correctly. Yeah. In chapter 2, I think there was Z-score, there was the standard deviation formulas. There was a formula for the mean, which, do you want to put that down?
Yeah, let's put it down,
Yeah.
just because.
Okay, what's the formula for the mean?
You tell me.
Why don't you tell me?
Okay.
I am professor. You are student. Anybody know? That was where we had our first interaction with the first Greek letter, the first 2 Greek letters. How do you find the average of a list of data? What do you do?
Add 'em all up and then
Add 'em all
try
up.
to
What
weigh
symbol is that? What
Sum.
symbol means add 'em all up? Yeah.
Yep.
Add
N.
Huh?
Over N.
Over N, I like it. But what are you adding? This doesn't mean anything without something next to it.
X.
Yes, there you go. All right. And X bar, same formula. What's the only difference between these two? This is A, and this is A.
Mean versus sample.
These are both means. This is a population mean, sample mean. I like it. Can you write the word population? No. Well, you can if you want to lose points. Okay. Don't think, yeah. No words are allowed on this formula sheet except maybe the words formula sheet. Okay, I like it. So then we get into probability. Are you facing the right way? Yes. By the way, disclaimer, I am not responsible for you copying something down incorrectly. So if I were you, I would double check all of these. Let's see. And I'm not saying I'm writing them down wrong. I'm saying you might read what I'm writing wrong. Does this look familiar? So that's chapter 3. Okay. And again, you guys realize you can just bring in all your old formula sheets. I just like to do this, it's a nice thing to jog your memories about stuff. Chapter 4 dealt with this stuff here. And then it's got, anybody remember that this was for here? No? Okay. This here? Anybody? Anybody ever seen that before in their whole life?
Yeah. It's like, isn't it how many, you're looking at how many things will happen?
Sort of.
Okay, I'll take a sort of.
So this is a binomial probability. So there's two possibilities. P and Q cover the probability of those two things happening. P was the probability of success. Q was the probability of failure. A success could be a dead body. So success doesn't mean happy. Success just means what we're looking for. Does that sound familiar? This is when we hit the two best freaking formulas ever for the mean and the standard deviation. They don't require a table or anything. Oh, shit, yes. So beautiful. You just have to multiply a few things together and you're done. Maybe? No. So that's chapter 4. Chapter 5 was uniform distributions and kind of like some continuous general distributions. At the time I told you not to worry about the mean and the standard deviation of a uniform distribution. Remember it was divided by 12? Remember that thing? The over 12 thing? Anybody? So we're not even going to write that down. It's not going to show up. So there really isn't anything from chapter 5. You should know how to remember how to set up a uniform. There's no formulas there really. It's all areas of rectangles. Chapter 6, let's put all the z-score stuff down here. Well, this is chapter 6. This is chapter 7, but it's all runs into each other. Chapter 6 is where we first did the z-score chart. Chapter 7 is where we did alternate universe Florida. Remember those great days? This is just kind of laying the groundwork. Does somebody remember what this was a part of? What theorem?
Isn't that where the standard deviation changes?
Yeah. And do you remember what theorem it was from that was related to this, that talks about this? Chicken, lettuce, tomato? Central limit theorem, yeah. A lot, okay? The bigger my sample gets, the smaller my standard deviation it gets, and of course that's where we got the infamous n greater than 30 requirement, right? Okay. N greater than 30 is not a formula, so do not write that shit on here. Neither is NP, NQ greater than equal to 5, all kinds of stuff.
So that's chapter 6. Chapter 7 was here. Chapter 8 is where we get these things. Oh, it's a little dead spider. That's freaking me out. Okay. It's always weird when I just sort of vomit up there all the stuff that's in my brain. Okay. That is chapter 8. What do you call all this stuff here? Anybody? What does this create? These things? Interval. What kind of interval?
Strong.
No, confidence interval. Sorry. trying to like do some charades. Confidence. Oh shit. Confidence intervals. How does this explain when you have to use T? Anybody see how this reminds you when you have to use T? Where does the T show up? Sitting next to what? S. Okay, so when you only have S, you gotta use T. When you have sigma, you gotta use Z. Hey! And of course, it has to be normal. You gotta be careful. Right. Okay. You're still seeing all this little dude?
Let's move you over there. Okay.
Oh my God! And then, let's see, what was it? That was chapter 8. And then chapter 9, hypothesis testing. The new thing would be, well, if you want to, you can put this down again. Just in case, even though it's already over there. And you can also put this down. Just to remind you that even if it's S, you still have to divide it by the square root of n, because some of you guys don't believe that.
That's chapter 9 and 10, or just?
This is chapter 9. All of this, what I'm about to write, is chapter 9. All right, there's the Z star for percentage problem. I think that's about it. Oh, wait. And then finally, oh, something I forgot over here. Shit. We got a little space up here. This little dude might show up, you never know. Right, that's the backwards formula from this. Remember this dude? No? And then finally, let's see. I got this thing. The one we just used. Oh my God. Does anyone have any suggestions on things to add to this? Pretty sure this is everything. I mean, there's the formula from chapter 10. The big ass Z star formula, if you want to look that back up, you can. That might be a bonus question on there. And of course, there's the other chi-square formula, if you want to do that bonus, that section 11.6 bonus. That other chi-square formula is this guy. So if you're not going to do it, don't write this down, but there's that formula, right? If you want to, you don't have to. But I think that's everything, but let me know. And I'll let you guys finish writing that down. Let me know now if anything should be added, because if not, this is all that can be on there. This is it.
So now, we could do what? We could do more of the practice final. I just want to remind you, I do have, as soon as I can get back into Canvas, I'm gonna unlock those solution videos. If Canvas is still down tomorrow, I'm gonna make an answer key, so, because obviously can't rely on you being able to see that, so hopefully it's back up, we'll see. As soon as it's back up, I'll unlock those solutions videos.
And
right?
it's
So-
to this practice
Yeah,
exam?
yeah. Yeah.
Are the solution videos on YouTube?
Oh, that's a good point. No, actually, no, they're only on Canvas, because I made them as Canvas Studio video.
Okay.
So, if Jeff would have been smart, he would have ported them over to YouTube also, but they only live on Canvas. So, nobody can get them right now. Aha. So now it's wide open. We can talk about practice final, we can talk about test corrections, if you still have test corrections to do, quiz corrections to do. We can talk about problems from homework, we can do more examples of problems. Wide open. I can see in all of your eyes, you're like, I choose nap. I mean, whatever is gonna get you ready for the final, I am all for. Chapter 4? Yeah, so this stuff, here, right?
Yeah, so it's.
Okay, so I'm gonna come over here. Got some board left over here, and I'll write big.
Scheisse. Are you okay there, camera? You're drunk a little bit.
It's not your fault, okay. So, I really hope when I give you this kind of problem, Sure. Is that good? Let's see. What am I trying to be careful about? I think it does. Yay, Jeff. Go, Jeff. So, it kind of makes me, not sure what my emotion is. When I give this problem and somebody starts doing this, and I'm like, wait a minute, what? I mean, please tell me. Now, I would never teach this way, but now that I've taught it, you've suffered through me deriving the equations and all this shit. What area am I looking? I already pointed it out, but I mean, isn't there an x and a p of x? Isn't it screaming for this section, right? Okay, so that's where we're living right now. Not this, obviously. It's got a little p, doesn't have a big x p of x. These two things. So first question I'll ask you here is, can you tell me what the probability of 5 is?
0.11.
Yeah, 0.11, right? Yeah, that's easy. So I ask you questions like that just to make sure you can read this correctly. What if I asked you verify, we sort of already did this, verify this is valid distribution. What would you have to say?
Yeah,
Or
that-
check, what would you have to check?
It adds up to 1, and then all.
What's
p-vax-
it?
P-vax adds up to 1.
Good.
And then all p-vax values are less than 1.
Not just that. They're all between 0 and 1. None of them are negative, none of them are greater than 1. If you write this, does everybody understand how that makes no sense? In fact, when somebody's written this, I've written which one. Show me which one. Which p of x is 1? I don't see any that are equal to 1. All right, so be careful. Don't tell me that I know what you mean. I do, and I don't care. I need you to be able to write it correctly so you can communicate to anybody. Okay. Now, can you take a minute
figure out what the mean is. How do you work with a formula that's got a sum symbol in it? If you cover the sum symbol, what does that piece tell you I need to do?
Multiply x by p of x.
Yeah, I need to make a column, because this needs me to add these up. I don't even have these yet. So how the hell could I add them? So I have to first create a bunch of x times p of x's. So remember, you could do L1, L2, L1 times L2, right? Okay. Okay. So let me see if I can do this. It's not bad, I think. What's that one, Jeff? Is it that? Probably. Yes. Gotta check my work here.
Yeah, you did it right.
Yay! And then how do I get the mean? Add them up, yeah. So the mean is the sum of these. So when I add those up, I get something. 1.42, 0.97, 4.87? Yes? I'm not surprised that I can add. I am surprised I can add those numbers right now, at this time. Now, what does it take to figure out the standard deviation? What steps do I have to take to figure out the standard deviation?
X squared times p of x.
Yes. So I first need to figure out a list of these, so that I can add them up, and then I can throw that number here and do the rest of it. So this is the first piece I want to focus on. I need a list of these, so I can add them up, so I can then subtract this from it, so then I can take the square root of it. Yeah? All right. So again, you can make L1, L2, this would be L3 is L1 times L2, this could be L4 is L1 times L3. Oh shit, Jeff. Oh shit, Jeff. Oh crap. 208. 1.92. Sorry. Could have done that quicker, Jeff. 2.75. Thank you. This is this is 12.1. Go, Jeff. All right. All right. I'm gonna erase this. Is that all right? Everybody got this here? This piece? All right. Oops. Everybody knows 11/6 is extra credit. Okay. So what's the sum of x squared p of x? $34.85.
Yeah.
Yes? Holy crap. Okay. Man. Okay. Physically tired. All right. So now, so I know the mean. I know the mean is 4.87. We've known that for a little bit already. So the formula for this is the square root of this thing minus minus the mean squared. So standard deviation is the square root of this thing minus 4.87. What mistake have I made?
You
Didn't
square it.
square.
Ah, that's the most common mistake. Poor little dude. Something feels off, but I'm gonna. What feels off, Jeff? All right, I don't know. I think it's probably okay. It's probably okay. Yeah, that's true. Okay. I'm gonna try to do this. Sure. Right. It's gonna be. Hold on. 3.45.
That's really asking for too much, Jeff. I know.
Somebody must have done it by now. No? Holy shit! That's not bad. No, sorry. I guess 3.45 is actually 3 point. Anybody else get it? No?
3.36.
337 I got. Right, rounding it up. Why did it take it 3 places?
Just do.
Because that's what you do when you're with Jeff Waller. Weird dude.
Can you do 4 places?
You could do 4. You have to do at least 3. A lot. Sweet. All right. I guess that kind of makes sense. Sure. Yeah, the average was 4.87, and like 11 is 6 something away from that, and so forth. So the average distance, yeah, that makes sense. Now, here's the ultimate thing. Let me show you. Let me remind you guys. Let's check this shit out. All right, let me just get rid of all this crap. So if I just put in here, oh crap, it's a weird angle, 2, 4, 5, 9, 11. Oh Jesus, somebody help me out, 0.47, 0.12.
0.11, 0.2.
Okay, if I hit stat and count, 1 bar stats, but now I have a frequency list. L2 is how frequently each of the data points showed up. So let's see what this says. Oh, look at that, that looks familiar. Yeah, there's the mean. There's standard deviation. Oh, I kick so much ass. It's a beautiful way to check your work. Okay. So what have I asked you? The question I always ask you with this problem is, what are you looking at?
What are you looking at? Oh, okay, I guess you're sort of looking there. Okay.
What percent of the data is within 1 standard deviation of the mean? Right? This should hopefully sound familiar. One of my favorite questions to ask. Why is that one of my favorites? Because we have the empirical rule. There's 68% within 1 standard deviation for a normal curve, theoretically. So here's a concrete example of us just seeing how much data is within 1 step. How do I do this?
Add and subtract.
From what?
3.337
No.
from the mean.
Oh, okay, there you go, from the mean. So put the mean in the middle, where it's supposed to be. Go up one of these, oh crap, 8.2 roughly. Go down, so this is plus a standard deviation and minus a standard deviation. So we get 1.53 something, I think. Double checking on that. Does that look right? I don't know. I always like to do this to remind me of seeing how much am I catching. So which data points did I catch?
4,
Definitely caught 4. What else?
5.
Definitely caught 5.
That's it.
That's not it.
Okay.
Where's 2?
Yeah, you caught 2.
Oh,
Caught 2. So caught 2, 4, and 5. I like it. And that might seem a little weird. That seems like it's, but what part of this tells me everything's pulled in that direction? Everything's been pulled in this direction. Everything has been pulled this way. Why?
Because of how frequent 2 is.
Say again?
Like 0.47.
Yeah, it's heavy. So think of these as weights. So this is the heaviest weighted thing. That's why everything's kind of like leaning that direction. So, what percentage did I catch? Don't tell me, I'll save some of you guys, don't tell me 3 out of 5. No, no, no. If I caught all the 2s, what percentage is that?
47.
47% so far. I also caught the 4s. How much more?
12.
So that's 59 so far. Caught all the 5s.
11.
So that's 70%, right? Wow. Okay. I like it. Okay. So that was a good question. I think, isn't the first problem? No, not the first problem. Which problem is like that on the practice? Number 3. And what's this one? What's the, things are being pulled in what direction there?
Towards the 7.
Towards the 7. So the mean should be higher than normal because the 7's the heaviest way to do. Yeah.
You think you could do an example of from like probability of A given B or?
Yeah, so the problem I gave here is a decent kind of problem. I might give you one like this, or I might give you like the contingency table kind of thing, because I like both of those. So let's do one of each, I think. Oh my God, this is not really doing this job. That's all right. All right. So does anyone know what I mean when I say contingency table? No.
What's that chart that has like an event and then another event? I don't know.
Oh, so, yeah, I think you got it. I think you got it. I'm not sure. So let's say I talk to, I don't know. Let's say I'm looking at dogs and cats. And I'm saying, you know, oh crap, let's see. Let's see how many they can either have, so I set them, oh screw it, Jeff. 0, 1, or 2 puzzles solved. So I'm trying to do an experiment to see which one's smarter, dogs or cats. Right. You guys know the answer to that?
Dogs.
Yes. In general, dogs are smarter. Which explains their empathy, because higher level intelligence is connected to higher levels of empathy, and I would definitely say the dogs have more empathy than cats. In general. Correct? Okay. So let's say, yeah, this is not the best to have numbers up there, Jeff. It's all right, we'll figure it. So let's say 3, 7, 16, and 25, 1. Sounds about right. Okay. So if I'm going to ask questions like, pick one thing from here, one element. What's the probability it was a cat? All right, what do I need to kind of do to be able to answer these kind of questions as they come at me?
Find the totals.
All the totals, I like it. So, 23, I already forgot what it's supposed to mean.
0 puzzles solved.
23 solved no puzzles, 12 solved 1 puzzle, and 17 solved 2 puzzles. There were 26 dogs, and there were 20, oh, that's so cool, I didn't do that on purpose. Sorry. So what, should I put 104 there?
No.
Right, this plus this plus this?
No.
Yay! No. should be 52, right? And if you check, 29 and 23 is 52. Yay!
Okay, you're not gods creating dogs and cats. No, you can't just double them out of nowhere. Okay. So what is the probability to pick a cat?
26 out of 52.
Yeah. So that would be 50%, right? So let's cut right to the chase. So Audrey was asking about givens. What's the probability I picked something that solved 2 puzzles, given that it was a dog? All right, let's do this slowly. What is special about givens? Every single probability problem would start with 52 on the bottom, except for this guy. Because in this example, what's going to be on the bottom of this?
26.
Yeah, there's 26 dogs. Now you sort of can't go wrong here. Now, if you put 17 on the bottom, you are wrong because given it's a dog. So I'm talking about one of these 26 things here. So what rows can I ignore? Just ignore those rows. Those don't exist. I threw them all out. So what's probably that I pick a dog? Given that I picked a dog, it's probably they got 2 puzzles right. 60? And whatever the hell that is.
Would it just, how many, oh, it'd be a percentage, so would it be 62%?
I don't know. Yeah, whatever it's gonna be. So remember, I like 4 decimal places.
Oh, okay.
So was it 6?
6, 1, 5, 3, 8.
And then you can make it a percent if you want to.
Are you, gonna require us to do a percentage?
No. Is that cool? I mean, that's one way you can have a given question, right? And I could ask you,
What about this one? This one always trips people up for some reason. What's probably I pick a cat, and they solved 1 puzzle.
5 out of 52.
Yes. So and is restrictive. Remember, it's the mean bouncer. You've got to meet all the requirements to be counted, to be let into the bar. They got to be a cat and solve 1 puzzle. There's only 5 things that are cats that solve 1 puzzle. And of course, the bottom is still 52 because it's not a given. It could have been any of the 52 things. Which is 0.09. So, 0.0973. See if my luck keeps going. Nobody's going to do it for me? Fine.
0.0961.
That's pretty good.
The only time the denominator changes is if it's a given, right?
Exactly. Because that's the given is the only time I have information. That's the only time they give me information. If I don't have any information, what could it have been? Any of these. If they give me information, I know it's not these, so I can only focus on those. Does that make sense? So it's only out of those. Given it's a dog, so how many things am I talking about? 26. Not all 52. Okay, maybe. Do you see, did we use any formulas here?
No.
Not really, no, we didn't. Because we didn't need to, because we have everything we need to count. It's when people try to use formulas on this kind of problem that stuff goes bad quick, right? The formulas would work, but they just are way worse than just counting what you do. Okay. The other situation you could do a given. Oh, what is the other situation, Jeff? Oh yeah, so like, let's say we had, oh crap. Well, screw it, I've already made a problem up. That's all I can have in my head. So see that part D up there, number 2? Probably is an even number given it's on green paper. So what is the bottom going to be for part D?
The number of things that are green paper.
Good. So what is that? How many green paper things? I tell you.
15.
No, there's how many pieces of paper total are there? We put the number 3, 4, 8, green piece of paper. 2, 5, 9, red piece of paper. How many pieces of paper?
Oh,
6. How many are green?
3.
3. So in part D, the bottom is going to be 3. Because it's given and it's green paper, so there's 3 pieces of green paper, yes? So it's out of those 3, so screw the red paper. How many of the greens have an even number?
2.
2. 2 out of 3, done. So it's literally ignore, just like we did, ignore the shit that's not given, because it's not a part of the problem. Given this, okay, ignore everything else. You can do the same exact thing on that kind of problem. Okay. Anything else? Trying to figure out what we're going to do on Thursday. Well, hopefully by Thursday, you'll have done some more homework. You'll have done more of this practice final. So you'll come with more questions. I think I could bring something.
Like
Yes.
pizza.
Well, don't get too excited. I will tell you, on the day of the final, I do bring cookies and donut holes.
Aww, that's so cute.
Because then I get some too. It's a nice excuse for me. I just don't eat anything because I'm going to eat so many freaking cookies and donuts. So I'm trying to set them up somewhere away from me, so I'm not just like, oh no, no, oh no. Anyway, so if you don't want to eat it, you don't have to. I'm not going to take a person, but I'm going to bring something.
It's at 3:55, right? 3:55
It
to
sounds
5:55.
familiar. Is that right?
That's what it says on the
It
list.
sounds familiar.
I think it's right.
I don't think it's right. So that's, wait a minute. Yes, that makes sense. So that's a slightly later start than normal, right? Which is good. Because if you forget, you come here at 3:30, hey, you're early. Thursday, I am going to bring a copy of what my office hour schedule is going to be that week. Because everything changes that week, yes? You're not going to meet your regular class time at all with any classes. This is the last week of classes. Next week is just your final.
Okay.
I'm getting a sense that we're done for today. Is that true? It's all about getting you ready for the final. So it's, if I don't see a ton of questions,
Yes, and we'll rank more questions on Thursday.
it's fine if that's not true. If you have questions, ask away. You guys doing okay?
We asked some questions.
What's up?
I already asked some questions.
Yeah, you're good. If you already asked your questions, you're golden. Okay, on Thursday, I'll bring some little worksheets to work on what I think is gonna give you some of the most trouble. Good, all right. So,
What you just said, would that be chapter 8 and 9?
oh, sure, yeah. Yeah, we could, I mean, if you have requests to make for what you want me to kind of focus on next time, shoot them at me. Send them over an email. Don't actually shoot. Please listen to what I'm saying.